Before we dive into the statement, it is important to first understand what particle accelerators are. The Gigantic Hadron Collider, LHC, operated by CERN, is a 17-meter wide band of superconducting magnets and is the largest and most powerful particle smasher in the world. It symbolizes the peak of human scientific achievement. In fact, it's so powerful that it could recreate the conditions at the beginning of the universe. Yet, could this machine, designed with the intention of revealing the universe's secrets, hold the key to something much more? CERN, founded in 1954, is one of the world's most renowned research organizations. With 23 member states and countless scientists, it is a center for development and collaboration. CERN's flagship project is the LHC, but it is just one part of a vast network of particle accelerators and experiments. Imagine a course, not for vehicles or planes, but for subatomic particles, and a test of expertise, perseverance, and even the fabric of space itself. The LHC accelerates protons to nearly the speed of light, sending them on a collision course that replicates the energy of the universe at the moment of the Big Bang. The results generate temperatures many times hotter than the core of the Sun. An array of magnets guides the protons on their journey, while complex cooling systems maintain temperatures colder than space. The beam inside the LHC is designed to fail in 4 places around the accelerator ring, corresponding to the positions of 4 particle detectors: ATLAS, CMS, ALICE, and LHCb. Each detector has a unique purpose, investigating different aspects of particle physics. Together, these detectors serve as enormous cameras, capturing images of these collisions. Researchers then sift through the debris, looking for signs of the elusive Higgs boson, also known as the God particle, and other anomalies that may reveal the universe's fundamental building blocks. By focusing on the microcosm, we gain insights into the cosmos. However, with each answer comes another question, and with every discovery, another challenge arises. The LHC is not just a scientific instrument, it is a demonstration of human curiosity and progress. It embodies our relentless drive for knowledge and our desire to understand the key forces that shape the universe. However, as we push the boundaries of what we know, we must also take into account the moral and existential questions that arise. What are the dangers of venturing into the unknown? Could our quest for understanding unintentionally unleash forces beyond our control? In the hallowed halls of CERN, where the limits of human knowledge are constantly tested, a revelation emerged that has left even the most prepared scientists uneasy. Brian Cox, a former researcher at CERN and an expert in particle physics, recently made a statement that both captivated and unsettled the world. His words resonate with chilling clarity. The goal of CERN's Large Hadron Collider is to recreate a small-scale Big Bang. Yes, you heard that right, a miniature version of the very event that gave birth to our universe. Cox also discussed the implications of this objective, highlighting the LHC's extraordinary capacity for groundbreaking discoveries, such as unlocking the Higgs boson's secrets and exploring dark matter, a mysterious substance that constitutes much of the universe. Imagine holding the power of creation in your hands, the ability to conjure the very essence of the universe. It is an alluring prospect, but one fraught with risk. This miniaturized Big Bang is not a hypothetical concept, it is an actuality that exists within the LHC. The temperatures, pressures, and raw energy inside the collider replicate the conditions that existed at the birth of the universe. It is like standing at the dawn of history, witnessing the birth of existence itself. However, with such power comes immense responsibility. The question remains: what if something goes wrong? In fact, something did go terribly wrong back in 1978. Russian physicist Anatoly Bugorsky experienced a catastrophe that would forever alter the course of his life. While working on the U-70 synchrotron at the Institute for High-Energy Physics in Protvino, Russia, a misfire caused a proton beam to strike him directly. The beam passed through his skull, entering the back of his head and exiting through his nose. Despite the horrific injury, Bugorsky remained conscious, even walking to a treatment center. His intellectual faculties remained intact, though the beam caused localized tissue damage, leading to hearing loss in one ear and partial facial paralysis. His case serves as a stark reminder of the immense power and potential dangers of particle accelerators. The risks associated with something like the LHC are not to be underestimated. The potential for unexpected reactions, and for altering the very fabric of existence, goes beyond science fiction. It encompasses real concerns voiced by respected scientists. One of the most disturbing and intriguing concerns related to the LHC's experiments is the possibility of creating a miniature black hole. Black holes are regions of spacetime with such strong gravity that nothing, not even light, can escape. These cosmic entities are like vacuum cleaners, devouring stars and lurking in the depths of the universe. The idea that the LHC could create such an entity, even on a small scale, is staggering to both the public and scientists alike. Could this black hole grow uncontrollably, eventually consuming the Earth from within? Scientists at CERN have assured the public that any black hole created would be unstable and would disappear quickly. Nevertheless, this remote possibility has sparked fear, speculation, and awe at the power we wield. Understanding how the LHC could create a black hole involves the basic principles of particle accelerators. When protons collide at nearly the speed of light, the energy released is so enormous that it bends the fabric of spacetime itself. Think of a trampoline stretched tight, and then dropping a heavy object onto it. The fabric stretches, and if the object is heavy enough, it could result in a depression so severe that anything nearby would be drawn into it. This is a simplified analogy for what could happen at the LHC, where the fundamentals of quantum physics behave in strange and wondrous ways. Some theories suggest that extra dimensions may exist within our reality, hidden from view. If these dimensions exist, the LHC's experiments could tap into them, creating a gravitational well that forms a small black hole. This strange behavior has caught the attention of prominent scientists, including the late Stephen Hawking. In his writings, he warned that the Higgs boson could become unstable at extremely high energy levels, leading to catastrophic vacuum decay, an event that would not just destroy the Earth but could potentially annihilate the entire universe. Sir Martin Rees, a prominent English cosmologist and astrophysicist, also expressed concerns about experiments at CERN. In his book Exploring the Future of Humanity, his words were not just precautionary, they were filled with existential fear. He described a worst-case scenario where a failed experiment could create vacuum instability, triggering a phase change that would ripple across spacetime, potentially engulfing the entire universe. Rees assigned a low probability to these disastrous outcomes, but he argued that even a small possibility should be taken seriously. The stakes are extraordinarily high, and the margin for error is razor-thin. If these extra dimensions exist, the LHC's experiments could, in theory, tap into them, creating phenomena beyond our current understanding. Some scientists speculate that the interactions within these hidden dimensions could lead to the discovery of unknown particles or even exotic forms of matter. The implications of such discoveries are profound. Could these extra dimensions hold the key to unifying gravity with quantum mechanics, solving one of the greatest mysteries in modern physics? Or could they reveal something far more unsettling? The fear that the LHC might open a portal to another realm is largely a product of science fiction, yet it is rooted in genuine scientific curiosity. If extra dimensions exist, then perhaps the universe is far stranger than we ever imagined. The question remains, if a portal could be opened, what would be on the other side? Beyond the purely theoretical dangers, there are more tangible concerns regarding the LHC's impact on our planet. Some have speculated that high-energy collisions could trigger unforeseen chain reactions, creating new states of matter or disrupting the stability of known particles. These fears, while largely dismissed by experts, highlight an important philosophical question. Should humanity engage in experiments that push the boundaries of knowledge if there is even the slightest chance of catastrophic consequences? CERN has gone to great lengths to address public concerns, conducting multiple safety studies and reviewing theoretical risks. According to their findings, the probability of a catastrophic event is infinitesimally small. The energies produced by the LHC, while immense by human standards, are still dwarfed by natural cosmic ray collisions that have been occurring for billions of years without any apparent consequences. Despite these reassurances, skepticism remains. Some argue that human error or unforeseen variables could lead to unintended consequences. Others believe that the pursuit of scientific knowledge should not be hindered by fear of the unknown. The ethical dilemma surrounding high-energy physics experiments is not unique to the LHC. Throughout history, humanity has faced similar questions, whether it was the development of nuclear power, genetic engineering, or artificial intelligence. Each technological leap has brought both progress and risk, forcing society to weigh the potential benefits against the dangers. Yet, the LHC stands apart in one crucial way. It is not merely an advancement in technology, it is an attempt to understand the very foundation of reality itself. The quest for the ultimate truth. At its core, the LHC represents humanity's relentless pursuit of knowledge. It is a testament to our desire to answer the most fundamental questions. What is the universe made of? What forces govern reality? What happened in the first moments after the Big Bang? The discovery of the Higgs boson was a monumental step forward, confirming a key component of the standard model of physics. But the search is far from over. Scientists are now looking beyond the standard model, seeking evidence of supersymmetry, dark matter interactions, and even quantum fluctuations that could reshape our understanding of existence. The possibility of uncovering new laws of physics is thrilling, but it also comes with responsibility. If the LHC or future experiments reveal something unexpected, how will we interpret it? How will society react to a discovery that challenges everything we think we know? For now, the LHC continues to operate at the frontier of human knowledge. It is a beacon of curiosity, innovation, and ambition. While the fears surrounding its experiments may never fully subside, one truth remains undeniable: our quest to understand the universe is as old as civilization itself. As we push forward, we must balance our thirst for knowledge with caution. The universe is vast, mysterious, and filled with wonders yet to be uncovered. Whether the LHC will unlock the final secrets of existence, or merely raise more questions, remains to be seen. But one thing is certain: the journey is far from over. Or hidden from our perception, yet could theoretically be accessed under extreme conditions. Imagine the LHC as a cosmic key, unlocking doors that have been sealed since the dawn of time. When protons crash with energies never before achieved on Earth, they could create ripples that probe these hidden dimensions. If these dimensions exist, the LHC could reveal them. However, it is important to note that while the LHC is undeniably powerful, there is no conclusive evidence to suggest it will open a portal to another universe, let alone to hell itself. Nonetheless, the allure of the unknown, combined with the mysterious nature of quantum physics, continues to captivate the public's imagination. So, should we be worried about the LHC and its potential dangers? It's easy to be swept away by sensational headlines and fears of global catastrophe. However, the truth is that the scientists at CERN are acutely aware of the risks involved. They have taken every precaution to ensure that their experiments are safe and continue to monitor and assess their work with the highest level of diligence. The potential benefits of the research, the breakthroughs in our understanding of the universe, the discovery of new particles, and the exploration of dark matter, are truly extraordinary. This is not just an exhibition of human ingenuity but a window into the very heart of the universe. However, like any great leap forward in science, it comes with its risks, and we should approach it with a balance of wonder, respect, and caution. The Large Hadron Collider represents the cutting edge of scientific inquiry, where theoretical physics meets experimental reality. Its true potential, to answer fundamental questions about the universe, such as the origins of mass and the nature of dark matter, is unmatched. Despite rigorous safety measures and detailed calculations, the LHC still evokes a sense of mystery and fear among some. The sheer scale of the machine and the energy it produces are inspiring, and each new experiment opens the door to uncharted scientific territory. While most scientists remain confident in the safety of the LHC's operations, there are still uncertainties. What if new, unexpected anomalies emerge that challenge our understanding of physics and the laws of the universe? The LHC pushes the limits of human knowledge and tests the boundaries of our control over nature. As particle collisions recreate conditions unseen since the Big Bang, the significance of these experiments raises existential questions about the potential consequences of altering the very fabric of the universe. Nonetheless, the LHC's achievements in particle physics have been groundbreaking. It has led to the discovery of the Higgs boson, advanced our understanding of the Standard Model, and opened pathways to potential breakthroughs that may one day shape our technological future. Despite the risks, the pursuit of knowledge remains one of humankind's most ambitious endeavors. The journey of scientific discovery is rarely without peril, and the LHC is no exception. Its experiments investigate new areas of physics where intuition no longer applies. For centuries, physicists have struggled to understand the fundamental forces of nature: gravity, the weak nuclear force, electromagnetism, and the strong nuclear force, all of which play a critical role in the construction of matter. The LHC stands as a testament to human ingenuity and curiosity, driving forward the pursuit of knowledge in ways that were once unimaginable. It is not just a tool for scientific exploration but a beacon of collaboration, bringing together the brightest minds from around the globe to discover the secrets of the universe. At the heart of the LHC's mission is the search for answers to questions that have fascinated humanity for centuries. What are the fundamental forces that govern our reality? What are the true building blocks of matter? How did the universe come to be as it is today? While the LHC has already achieved remarkable feats, such as confirming the existence of the Higgs boson in 2012, it continues to push the limits of our knowledge. Each collision of protons within the collider brings with it the potential for discovery, from new particles to previously unobserved phenomena. But with such power and potential for revelation comes the responsibility to exercise caution. Scientists, though confident in their safety measures, remain ever aware of the risks, both known and unknown, that come with experimenting at the very frontier of physics. The idea of manipulating the forces that shape the universe, or even creating phenomena like miniature black holes, inevitably raises concerns. It is a reminder that scientific progress is not without its dangers. Despite the stringent protocols in place, the unknowns are vast, and each experiment comes with a certain amount of uncertainty. Theoretical physicists such as Stephen Hawking warned of the possibility of disastrous events, like catastrophic instability or vacuum decay, which could theoretically result in unchangeable outcomes. While the probability of such events is low, their very possibility sparks public fear and fascination. For some, the LHC is a symbol of humanity's unrelenting drive to dominate nature, a desire to harness and control the forces that govern the cosmos. For others, it is a tool of enlightenment, a means to peer into the fundamental nature of reality itself. The pursuit of knowledge, however, is not without consequences. As with all scientific endeavors, the road to discovery is fraught with ethical dilemmas and unforeseen risks. What happens when the power to explore the universe's deepest secrets falls into human hands? Should we, in our pursuit of knowledge, stop to consider whether we are ready for the answers we might find? The notion of opening gateways to other dimensions, or even other universes, though largely speculative, feeds into our collective imagination. It's easy to see how the combination of extraordinary scientific progress and profound existential questions could give rise to fears of unintended consequences. It is a delicate balance between discovery and caution, a balancing act that has defined humanity's journey through the scientific revolution and beyond. At the heart of these concerns lies a deeper question: how far are we willing to go in the name of progress? And what are we prepared to risk in our pursuit of the unknown? In the end, the LHC is more than just a machine. It is a reflection of humanity's insatiable curiosity, our desire to understand the universe in its most fundamental form. It is a symbol of both our greatness and our vulnerability. While we may never have all the answers, the questions that the LHC raises are central to our understanding of the cosmos. Even as we push the boundaries of what is possible, we must remember that every discovery opens up new paths of inquiry, new challenges, and new opportunities for exploration. Whether it eventually turns out to be a doorway to a deeper understanding of the universe or a harbinger of unforeseen consequences, the LHC's legacy will undoubtedly shape the course of scientific inquiry for generations to come. The pursuit of knowledge is a powerful force, and as we continue to explore the mysteries of the cosmos, we must tread carefully, mindful of both the dangers and the promises that lie ahead. As the LHC delves deeper into the unknown, its experiments challenge not only the boundaries of science but also the limits of human imagination. With every breakthrough, we find ourselves confronted by new mysteries, each answer leading to more profound questions. The deeper we look into the fabric of reality, the more it becomes clear that the universe is far more intricate than we ever imagined. But what if the discoveries made at the LHC force us to reconsider fundamental aspects of our existence? What if, in probing the fundamental forces of nature, we stumble upon something that defies explanation, something that challenges our understanding of time, space, or even consciousness itself? These questions, though speculative, highlight the profound implications of the LHC's work. It is not merely a machine for smashing particles, it is a tool for uncovering the hidden architecture of reality. What we learn from it could one day lead to technologies beyond our wildest dreams, perhaps unlocking secrets that revolutionize energy, space travel, or even our perception of life itself. Yet, as history has shown, every great leap in scientific understanding comes with a cost. The discovery of nuclear energy, for instance, brought both boundless potential and existential risk. The splitting of the atom paved the way for technological advancements but also ushered in an era of unprecedented destruction. Could the LHC's discoveries lead to similar unintended consequences? Could our search for knowledge open doors that we are unprepared to walk through? It is this duality, this delicate balance between discovery and responsibility, that makes the work of CERN so compelling and, at times, unsettling. While the scientific community remains steadfast in its assurances that the LHC is safe, the sheer scale of its potential continues to inspire awe and trepidation in equal measure. At its core, the LHC represents humanity's enduring quest to understand the cosmos. It is the product of centuries of intellectual curiosity, a testament to the power of collaboration and ingenuity. The pursuit of knowledge, however, is never without its risks. The unknown has always been a source of both wonder and fear, and the deeper we venture, the greater the stakes become. Perhaps, in the end, the most profound question is not whether the LHC will unlock the secrets of the universe, but whether we are ready for the truths it may reveal.